Today we will talk about the advanced memory systems and for the artificial intelligence. So how to get from the rack to the memory and how to get from the graphs to the metagraphs. And so a bit about myself. So I'm Ukrainian based in Berlin, and I start working as software developer when I was at school. So I have something like 23 years in software. But I'm more the self-sovereign identity guy, so I'm more focused on identity, decentralization, sovereignty and privacy of the data. So for last 5 years I stay in the sovereignty domain, and for last 2 years I build in the privacy focused and privacy first artificial intelligence. So you could find me on LinkedIn, YouTube, Medium, PeerTube. So probably you watched this video already on my YouTube channel. And my core values, it's individual freedom, the self-development and constant improvement. I keen to democratize the access to the artificial intelligence and knowledge in general. I really believe in property rights and privacy rights. So what I'm doing and my key, first of all, the key is the local first and privacy first. Focus on the self-sovereign and soft data assistant. I know that it's a lot of terminology, maybe some of them are not clear to you, but it's powered by the memory system that focuses on the understanding. And on our website, you could give it a try. So it's a safe space where you could talk about some sensitive topics, and you will be sure that this data will stay on your phone, nobody will know about it, and you have the full control and ownership on your data. So the huge challenge of the modern AI agents actually is the data. First of all, we have the data hunger, so we have less and less data that's available for the training of the new agents. This data struggle with quality because they could be biased, they could be not aligned with your values. And when you just try to train the model on the massive amount of data in internet, you get a lot of Russian propaganda, conspiracy theories and all of things. But the huge problem nowadays with data in general is the ownership. So you could not prove the ownership of your own data and the privacy, that if you're talking, for example, with the ChatGPT, they will just use your chats for the training of the model without the fair rewards. And we're really keen to change the situation actually. So the majority of the data nowadays is closed. They locked in platform, they locked in the people heads, and maybe people are not so confident to share this data because they lack of protection, they lack of privacy. And the answer to all the things is the sovereignty of the data. It's the data that you own. You don't give the data to somebody else. You control your data yourself, and you give the consent if you want really to share this data with the other people. But it happens transparently on your behalf. And for sure, you always could get the insights from your own data. And we focus on something slightly different from the big data house, because if you want to own the big data, it means that it's more about the big enterprises, big data points. You need some data engineers around to make sense of it, and usually it's more about the platforms than yourself. And we propose the slightly different domain. We propose the concept of the small data. It's data that you care, that data that you could process with your brain, and maybe with the help of the AI assistant, it's easy to digest, it's easy to make the decision, and it's more about yourself, not about the platforms, not about your shopping histories. It's more about your thoughts, your ideas, your beliefs. And we also separate this data on the hard and soft and metadata. And the hard data, it's where the majority of the artificial intelligence agents focused. They try to analyze your emails, your bills, your calendar, and so on. But we really believe that a lot of value sitting in your head as a values, feelings, thoughts, ideas, some key drivers, and we want to extract this soft part and then connect with the hard data points. So how we could do it? We figured out that modern AI agents more focused on the RAG, and every week we have slightly different RAG framework that allow or promise to fix all the broken things from the previous RAG strategies. But we observed that RAG is not enough for the AI agent because it's more focused on documents. It's like this episodic content and memory-like systems. It doesn't know how to forget the thing. It's lack of this association building that our brain just wired, yeah, and it's just retrieval without really the understanding of the retrieval data. So how we could improve it and what we could use instead of the RAG. So it's a memory systems, and why you need the memory system? Because it's a temporal aware and temporal reasoning. So we observe that without time, your memories doesn't make much sense. So we always need to be aware when it happens. Is it relevant right now? And are we talking about the past? Are we talking about the future? The importance, attention, and focus, it's also matter because you could have a lot of memories, but what's relevant to your current conversation, what's relevant in general to your current life. And another observation that our brain have this constructive recall that are quite complex process but could be error prone. So it's yet another thing that we want to get the best of the constructive recall but fix some bugs, let's say, that human memory have. And for sure they're forgetting. We really want to know what's to forget and when. So we have a lot of systems or memory system on market like Cockney, Zap, Memory Zero, Memento, and all of things. And Memory Zero just make the paper that describe all these things. It's a cool project. Allow them. They mainly Python, and we just realized that we need our own memory system. Why? Because first of all, we run on the user device in this heavily privacy focused manner with the limited environment. So we simply could not easily run the Python projects on the user device. We need this temporal and context aware memories that, for example, Zap partially give the answer to this question, but unfortunately not fully, because we observe that people rarely use the fixed timestamps when they talk about time in the chats. They use some more abstract like soon, future, in 2 weeks, in the next month, and somewhere in the future, And unfortunately, we could not just stamp the fixed time to this. We need something more flexible. And for sure, we want to have the ability to forget, to pay attention, to decide what's matter in a flexible way. And it requires some really complex logic, actually. That's why we're trying to build our own memory. So the graph are the core of the memory. So we have the benefits of connected data, the semantic memory that somehow compress these encyclopedic facts. And it's, as I mentioned, it's a form of data compression, and it's maintain the complex relations. It's allow us to create the fractal and recursive structures and hierarchies and all of the things that quite similar to the structures in our brain when we're talking about the memory. But what we observe that the graph itself is not enough. So he needs the ontology, and ontology bring the understanding and the meaning layer and the reasoning layer to the graph, that instead of just strings, you have some interoperable structures that are understandable to others, that explain what all these strings really mean. So you need to pair your graph with the ontology. Also, we see that just the directed graph that have the subject, object, predicate that are used everywhere for a couple of decades are not enough for the memory. because our memory beyond more complex than the binary relations. So the binary relations actually uh, it's too limited, and we have no mechanism to add, for example, the metadata to the edges. We have no way to express some complex ontology metadata. We have hard times to express the temporal information for the edges and nodes. That's why we need something that go beyond of the triples. So the triples and directed graphs are not enough. So one good discovery was the hypergraphs. So the hypergraphs is the generalization of the graph that actually what they do, they offer you the hyper edges that allows you to connect the multiple nodes with a single edge. And it's already quite cool because you capture the multimodal information, you could capture the multilingual information. It's a lot of complex entities as edges, but we discovered that sometimes you want to refer this edge as a node, and unfortunately it's not fitting well to the hypergraph mathematical model. So then our research lead us to the metagraphs that are most powerful generalization of the graph. So you have the hyper edges as a hyper graphs have. You have the meta nodes actually that allows you to have the nodes that contain the graphs, and your edges actually could contain the graphs. And nodes and edges could be used interchangeably depending on the context, and it's super powerful. But the challenge was the metagraphs and hypergraphs that we're not yet there. And we don't have the databases that work with these complex data structures. We don't have enough research for the metagraphs, and we have the lack of the ontology tools. So if you go this path, you completely leave to yourself to manage all the things, and we simply not ready to build our own database from scratch, for example. So then we discover that maybe we could benefit from the layered graph. And layered graph, actually, it's a quite simple idea that you have the edges, and on the next layer you could use the edges from the previous layer as a nodes. And then you could build this layered hypergraphs if you really want. That more simple than the metagraphs and could be fit to the some databases to some extent. And you could read more about the layered graphs because they married somehow the property graphs and the RDF graphs in the same data model. And for example, some databases like Neptune use them. Another quite interesting concept that move more from the hyper edge to the meta nodes, it's the graph of graphs. And then the cool thing about the graph of graphs is a hierarchical structure where nodes could host another nodes, or the subgraphs. It's have full support of the RDF for the named graphs, as they call this concept, but you have the challenge that your node could have only one single parent, so you could not share the nodes between the different parents and different locations, unfortunately. So then at the end I sit for a long time and take all these possibilities of the metagraphs, hypergraphs, all this concept of the meta nodes and hyper edges, and I just figure out that at the end we talking about some kind of the subgraphs all the time, and we need something complex for the relations. So, and I discovered the concept graphs that actually the same age as me, because they was invented somewhere in 1984. And idea of the concept graph is quite simple. You have the biparty graph where you have the separate node for relations and separate node for the entities, and actually then your edges just connect the relation with the entities, and that's it. And now we could have extremely complex relations with the multiple entities. We could easily build them. But what I made as a next step of the concept graphs, that I represent this complex subgraphs actually as a nodes. That we could, for example, have the node that represent not just complex relation but something more complex thing like fact, or complex thing like event or life experience or memory. And we just persist it as a node that have the connection to all the things that matter in this context. And it's our main idea and the good compromise between simple directed graphs and all the tools that support the simple directed graphs and more advanced data structures that we could use. But we still need to go all this path, because with the metagraphs we have the better support of the multilingual data, fractal data that are crucial for the memory and brain modeling and homoiconic data. So this future of the metagraphs is still matter, but we're not there, and right now we have the good compromise that allow us to build extremely complex memory system. So that was all that I was keen to share with you. See you next time. Choose.